Hello and welcome to today's webinar. Say goodbye proprietary GPS devices. Hello TerraGo Edge. This is brought to you by our sponsor, TerraGo Technologies. I'm Bethany Chambers, Digital Operations Manager for North Coast Media, publisher of GPS World Magazine, and I will be your event manager today. Before we begin, I'm going to go over some ways that you can participate during today's presentation. Although you are currently in a listen-only mode, we encourage you to ask questions throughout the presentation. Just type in the text box at the bottom left, then click Submit to place your question in queue. You can also submit questions via Twitter by using the hashtag GPSWorldWebinar. Questions that were submitted during registration have already gone to our panelists and may be covered in this webinar. Some questions may also be answered in an upcoming issue of GPS World Magazine or in one of our e-newsletters. We strive to answer as many of your questions as possible. If you'd like to share this event with colleagues, you can do so at any time by the Share This box at the left-hand side of your screen. If you experience any technical difficulties during today's event, use that same Q&A box at the bottom left to tell us about your issue and click Submit. And Assistant Producer Joelle Harms or I will personally assist you. Finally, a recording of this webinar will be available tomorrow afternoon at gpsworld.com/webinars. You can get to that page now and bookmark it by clicking on the header above your slides. A link to the on-demand recording will also be emailed to you when it is available. Now I'd like to turn today's event over to our moderator, GPS World Editor and Publisher, Alan Cameron.
Thank you, Bethany, and welcome everyone to today's webinar. TerraGo offers single-use GPS handheld devices and enables mobile workers and field crews to collect field data, share that data with others in real time using any iOS or Android device, and sync that information with headquarters at low cost. Our speaker today is Michael Gundling, Vice President of Product Management at TerraGo. He's going to explain how the device works, give a demo, and then we'll turn to your questions. Many of these questions were submitted as you signed up for the webinar. We will take others live online, that is by email, using the process that Bethany just described. Now, Michael's going to show you how to capture data from any iOS or Android device, synchronize project updates in real time, manage projects, job sites, and tasks from a single dashboard, and monitor field worker locations for safety and efficiency. Michael, take it away.
Thank you, Alan. I'm going to get started talking about the 5 reasons why our customers and why we believe more people should be replacing proprietary GPS handhelds with BYOD mobile devices. The mobile revolution that started in 2007 has bypassed many folks that are out in the industry, out in the field, collecting GPS data with single-use GPS devices. In our view, and we mean to be provocative when we say this, the world just doesn't work that way anymore. And there's a democratization of GPS that's happening. Meanwhile, there's an amazing amount of R&D and technology advancement that's happening, especially on the iOS platform and Android. So all these mobile devices, they work with the cloud. They're multi-use devices. They connect to the Internet of Things. And today, though most folks don't understand it, you can actually turn your phone or tablet into a centimeter-capable GPS receiver. We'll talk to you about how to do that. And first, let's go through some of the reasons why you would consider doing that. Number 1 is cost. The bottom line is that maybe it made sense years ago to spend several $1,000s or more for a single-use proprietary GPS device that only does one thing. Today, the truth is that our customers are saving 50%, even 90% on their costs by replacing these proprietary handhelds and all the associated back-end software that goes with them. The truth is, the only thing that matters to you is what are your performance requirements? What are your accuracy requirements? What are your workflow requirements? So you can actually go to our website and look at an ROI calculator to get past the messaging, but go to the marketing, go past the marketing and get to what is your unique circumstance. What are your costs and how does it work for you? The second reason to switch is the hardware. So today, it's amazing that every time there's a new generation of an iPhone or an Android device, the cameras get better, the speed gets better, the memory, the performance, the bandwidth, the internet access, everything, the GPS chips are getting better with every generation. So mapping and survey-grade GPS receivers are available, and that's the hardware that you need for GPS performance. Your GPS accuracy requirements should determine a GPS receiver that you use connected to a modern mobile solution, and it shouldn't constrain you to using an outdated proprietary device. The third reason is software. So when we talk about outdated, let's be clear. These devices are still running Windows Mobile, which even Microsoft stopped supporting in 2008. It goes back to 1996. These devices and the software that underpins them were born, devised, engineered, built, and abandoned before the cloud came into existence, and yet people are still using them. So there are so many things that we get to ride and stand on the shoulders of a multi-billion-dollar investment from Apple and Google and other players like Samsung that mean that you can get a superior software experience and capabilities with a modern mobile solution, far more than you're ever going to achieve with a proprietary GPS device that runs an outdated, deprecated operating system. User productivity. So today, I read a statistic that was over 70% of adults use location-based apps in their everyday life, right? So we always use our iPhones to get somewhere and things like that. The truth is that these users come into the field trained on how to use these devices and to use them in a multifunctional type of way. We no longer carry pagers and digital cameras and all these different devices. We actually have an amazing computer at our fingertips, and it does so many things for us. So field workers, they can use that GPS device called an iPhone, and they can actually capture data, and they can use other business apps, phone, email, messaging. So the productivity improvements are enormous. The other thing is training. Those 70% or more people that come into a workforce knowing how to use a location-based app, the same with TerraGo Edge. Any modern mobile solution has an intuitive native interface that enables users to intuitively get up to speed. No more paying thousands of dollars for training to go through an esoteric or proprietary user interface or workflow. This is all very simple. As easy as you can post a picture to Instagram, you can capture GPS data that meets your accuracy requirements, attach forms, notes, videos, photos, whatever you need, and you can do that all intuitively with little to no training. The power of OpenGPS for us means that although we're here at GPS World and there are a lot of GPS experts in the audience and subject matter experts, we are open and agnostic. We actually don't want to have any religion about which device you need. In fact, with my iPhone, I've paired it to a Bad Elf, an SX Blue, an EOS device. I can take my iPhone and I can turn it into a 5 meter, 3 meter, 1 meter, sub-meter, or centimeter capable receiver. And the really amazing thing that GPS World has talked about in many articles is that you can do all that in real time without post-processing. That is another huge benefit to our customers. The benefits of real-time data collection mean that you are freed from the time and expense of all the post-processing, and you get the accuracy you need. If you can find that data point today, you can find it tomorrow. The truth is that there are a variety of correction sources that are getting better all the time. So all of the space-based augmentation systems, WAS, real-time networks, all these different setups that enable you to collect data in real time are immense time savers in the field and time savers from an operational point of view. And you typically, and our friends that are GPS subject matter experts and the people at TerraGo will tell you that 99% of the time, you don't actually need to do post-processing to improve your accuracy. Our next version of TerraGo Edge is available in the App Store, and it's a pending release. It should be available anytime now. So we submitted it about 12 days ago. Just waiting for Apple to release it to the public. And it has a lot of new features. For those of you that don't know, SX Blue and EOS are two of the leading receivers at the high-precision survey-grade end of the scale. We have a lot of other features, which I think will make more sense if I'm able to give you a demonstration and go into that. So allow me now, it may take just a moment with the screencasting software, to launch the screen share, turn that on, and I need to share with you my iPad and an iTouch that I have here. So what I can show you is a very simple app. And this app starts with the collection of what we call notes. Some folks might call them GPS records. So the idea here is that we are able to use any device, any iOS or Android phone or tablet, and we are able to connect those to whatever GPS receiver you need. So what I'll show you now here on TerraGo Edge on the iPhone or iTouch interface is the application enables you to come into system settings. I'll wait just a moment for the screen to refresh. You go into system settings, and with the touch of a button, you can turn this phone into something more than an iPhone. You can take your location information, fully integrated with a Bad Elf, an SX Blue device. You can get centimeter accuracy. You can get all the raw NMEA data that you need for your GPS records. You can actually establish restrictions to make sure you get the quality and the accuracy that you need. We have customers, for example, in wetlands delineation, so they need sub-meter accuracy to do that type of field work. What you do in TerraGo Edge is quite simple. It starts with the concept of a notebook. I'll select one of our notebooks here. This is AccuMark, which is a utility mapping company. Here I'm able to go in and view the existing GPS notes that have been taken. Now these notes can take many forms, and it's entirely customizable. So you can create the form, the structure, the data dictionary, if you will, that you need for your business. Unique to your requirements, completely customizable. So if I look, this is a form that's been completed. It has any number of different types of fields. You can actually include signatures and things like that. And this is what the customer's workflow required, is the ability to go out into the field, take these photos, be able to sketch a utility test hole, be able to take photos of the utility test holes, and also capture the GPS data associated with them. My screencast went away, sorry. So the ability for the user to go in and create notes and look at the prior notes of the field is the other users in the field is enabled by syncing through the cloud. So you're able to sync through the cloud so that you can see all the notes connected by all the different users. Now, it is not going to be a test in accuracy today for our demonstration because I am sitting in an office building. But you can see here that all the GPS metadata that is available to me is here, including number of satellites, horizontal accuracy. I can actually look at the map view of where I am, and I can show you that you can use any map source with TerraGo Edge as well. So you can go in and select a map, and you can select an online web map. You can actually select, sorry, I'll wait for the refresh on the display. You can actually select different types of online maps. Any online maps you have, we also integrate with ArcGIS Online and other subscription services. You can also have the offline maps. We have a lot of customers like Logan Simpson that do environmental work and environmental planning and engineering, where they go into very rugged and remote terrains. So they take offline maps, and they're able to do their job, do high precision GPS data collection without requiring any connection to the network. I would also show you, for example, that we have the capability to collaborate out in the field. So for our pipeline inspection customers and folks that actually, like AccuMark, that do the different types of work that we have. I'm sorry, I lost my connection again. You're actually able to assign tasks and share those tasks with other workers. So if I bring that up on the iPad, and I'll wait for the refresh. I think I'm asking a lot of our webcasting software. you can actually create a task note, a GPS note, and let's say that an inspection yields damage or something like that. I can assign this task note to a user. I can give them any status option that I want. So this one is not started. I can say here's a due date. And I won't go through all the different types of options we have, but because you are using a modern kind of mobile collaboration app, you can do a lot of different things that are inherent or enabled by the iOS and Android platform upon which we build. So hopefully that gives you a glimpse into how we can use TerraGo Edge as anything from a 5 meter to 3 meter to sub-meter, centimeter level accuracy receiver. I will now go back to the slides. Pardon the delay while I transition. I will go back and I will turn it back over to Alan for Q&A.
All right, thank you, Michael. We've received, I think, a record number of questions prior to the webinar, 155 actually, if you can believe that. We won't have time to address all of them, but we're going to ask Michael to answer some of the prominent ones. Michael, you've just answered the question that was most frequently asked by different registrants, but I'll ask you to just review it again. You also covered it in your presentation just now, but so many people want to know what level of accuracy is available using this approach. Can you just review that ground again, please?
Sure. The power of having an open GPS approach means that we can support whatever accuracy level you need. So we have customers that are doing just using their iPhones, believe it or not. 5 meter accuracy is enough for various types of field work that they do. And within some organizations, they actually map, I think it was Charlie Trimble that coined the phrase accuracy is addictive. They actually map valves and things like that at centimeter accuracy or sub-meter accuracy. But then for a maintenance crew to go find that valve, especially if it's an above-ground valve, they're able to actually just use their iPhones. So it gives a very flexible way for TerraGo Edge to help our customers kind of be an any meter solution. So you can get real-time centimeter solution with an RTK-capable receiver like an EOS Aero 200, or you can get sub-meter or 1 meter, or you can take the onboard GPS and get the typical 3 to 5 meter experience. So any range of accuracy is what TerraGo Edge supports.
All right. Another listener wants to know how to sync past a network firewall using this approach.
Yeah, it's quite simple. So TerraGo Edge is available as a subscription option, either as hosted or as an on-premise installation. So for those who are installed on-premise installation, it's very simple. It's like all their other cloud-based apps. It's just opening up a port to get through the firewall so that users can actually sync to that server over the internet. Of course, we offer a hosted solution. So for those that don't have network expertise in-house, we're able to host the solution for them as well.
Okay. Signaling our international attendee level, we've got questions from Asia and I believe either Latin America or South America. One listener writes in, I work in tropical forest environments. How effective would TerraGo be in heavy canopy areas?
Right. And I would change the question to how effective would any independent GPS receiver be in those conditions. And for that, I would turn to our partners at EOS and SX Blue to help explain how to do. Clearly under canopy, something that is capable of centimeter level performance is not going to get that under canopy. So it's difficult to say depending on the canopy and the conditions, but the truth is that these receivers will do as well as the much more expensive proprietary handheld devices under those operating conditions. And you have lots of different options for doing that, whether you go with a high-end receiver like an Aero 200 or an SX Blue 2 to get the sub-meter. The performance is going to vary depending on things like canopy and urban canyons and your operating environment. Best thing to do is actually do a test, get your hands on one of these devices and there are a lot of vendors that will supply those. You can actually rent them, take them in the field, find a geodetic monument, and stand on that spot, take it and see what you get, and see if you can do your own test to see what it's like really for your environment.
Okay, and similar question, or a similar answer, most likely, to this question, is an external GPS antenna required?
It only is if you need something better than what the device gives you. Like the typical commercial phones do give you 3 to 5 meters. There are some other devices that are out there from folks that have, for example, ruggedized Android tablets that have GPS boards that can actually attain much better accuracy. So a GPS receiver is required only to the degree it meets your requirements. So whatever you need to pair with TerraGo Edge, TerraGo Edge is open and able to accommodate those accuracy requirements.
All right, a remark for our audience now. I'm reading from the pre-submitted questions for the webinar. I see 1 or 2 have come in online. I encourage you, if you have any questions as you're listening to the webinar, go ahead and submit them through the Q&A box at the bottom left of your screen, and we'll get to just as many as we can. Turning back to you now, Paul. Here's one listener who writes in specifically for mapping roads, and he wants you to explain in detail how what he has to do to be able to use this device to be able to map roads at a sub-meter accuracy for NG911 use.
Okay. So I think it's next generation 911's work, and I think we have customers that map roads. We support the capture of points, lines, and polygons. There are different ways to do that based on doing center of road and offsets and things of that nature. For sub-meter, for example, you could just take an EOS Aero 100 out into the field, paired with TerraGo Edge, and we actually have the ability to automatically draw polylines based on recording of GPS positions as you move along a road. So that'd be one simple way to do that.
How would you handle field inspections of assets that have already been located? Or one listener writes in, for example, field inspections of stormwater assets. These are assets that have been located but need to be re-inspected every so often. Let's say the assets are in an Esri geodatabase. How would you go about performing those re-inspections with TerraGo Edge and tie that data back into your geodatabase?
That's a great question. We have a number of customers doing that today. We've been connecting and working with and partnering with Esri since 2003. There are a lot of different ways to do that. You can pull shape files out of Esri, bring them into Edge, and you can go inspect those nodes based on that source. We also have connectivity ArcGIS Online, so you can actually view those assets directly online if you have an ArcGIS Online subscription. And so we have an open geodatabase. So a lot of different ways to pull those existing geospatial records, those features and those geospatial features and their attributes into Edge, and then take them out into the field, and you can update existing fields. You can view and navigate to the different points that come from that data source. And then we have lots of different ways for you to update your ArcGIS system. So you can actually use WFS, online interface. You can actually export shapefiles again from TerraGo Edge to update your ArcMap geodatabase, or you can also do KML. You can also use that to visualize in Google Earth, of course. And we can export in CSV, GeoJSON, lots of different formats. So the truth is, to answer that question, there's easy data in, it's easy data out. Again, the concept here is a very open system. Unlike the existing traditional proprietary GPS devices, we don't charge for data formats and we don't try to lock it in. It's all in a PostgreSQL database, and that database is a completely open one, and we surround it with lots of interfaces to help our customers get data in and out of ArcGIS and other platforms.
All right. many navigation systems, many positioning systems have mechanisms to alert users to performance shortfalls and solution integrity problems. That is, if there's a problem with the satellite system itself out in space, or some kind of ground control software. GLONASS, for people who incorporate GLONASS into their solutions, has had a couple notable problems recently in this regard. Some systems have things like RAIM, Receiver Autonomous Integrity Monitoring, to alert users, oh, the data you're getting is not reliable, due to a satellite problem or some kind of system problem such as that. What comparable mechanisms are in place for Android devices in this respect?
Okay, I think the answer has two parts. One varies on the manufacturer and how they deal with correction and sources and the performance of a GNSS receiver and how it manages those types of conditions. At the end of the day, for the field user in TerraGo Edge, it's going to be about the presented GPS metadata. So even though we're in a building today and I really couldn't give a great demonstration of pairing it with a powerful receiver like an EOS or an SX Blue receiver, you can see the number of satellites you're connecting to, you can see the horizontal accuracy, and you can establish policy proactively that allows you to control and restrict data capture. So you never capture bad data, you always capture data that meets your requirements, and you can actually also warn the user that you are now slipping out of a desired accuracy level. So there's a lot of performance and quality control, both on the receiver side, but then also for the end user in TerraGo Edge.
One listener writes in specifically about monitoring maintenance and repairs, wants to know how to adapt this system to monitor maintenance and repairs, for example, project status.
Yeah, it's very simple. We have a lot of customers that are doing that today. So the idea here is that you have the ability to create any type of workflow that you need. For maintenance and repairs, for example, we have folks that create task notes and send folks out to do inspections. When the inspector finds something, the power of the system is it allows them to turn it into a task for someone else. If they see damage, they can actually remediate much more quickly, because rather than coming back on a paper form and being processed through an administrative function, they actually immediately over the cloud in real time say, there's damage on this pipeline, for example. And they can assign a task to a maintenance crew to come out and actually repair it. So there are a lot of different ways, but at the end of the day, it's not a prescriptive workflow, it's a very open workflow to allow you to assign workers tasks. The other cool thing is that we have a user locator feature. So you can actually see where your workers are out in the field. So if you get a service call or an event or a water main breakage or something like that, you can actually dispatch through TerraGo Edge based on where my crew are located. So there are a lot of different functions and cool workflow and collaboration features that we didn't have the chance to get to. But for anybody that's attending the webinar, I'd be happy to kind of go through their specific scenario and show them what we do and what we don't do.
I'm going to ask you to go back over some ground that you covered when you talked about the need, or the not need, the absence of need for post-processing. We've got two questions from listeners that get at this issue. One of them asks, is there any smartphone which would output raw measurement data in real time? And another one who asks, may I post-process? And if so, how much memory do I need on my device?
Yeah. Typically, our customers, and that we do have some that still choose to do that, although it's becoming more and more of an anachronism, they choose to post-process. There are a lot of free post-processing services. They typically do that from the back end. So married to the other question, the great thing about TerraGo Edge is we capture all that raw GPS data, all the attributes, the dilution of precision data, all the different horizontal and vertical accuracy, the number of satellites, all the information, the full NMEA GPS data stream is available to you to post-process against other reference stations or services, and you can do that in a number of ways. And there are several, and I've read about it on GPS World on a couple of occasions, several free services for doing post-processing of data.
Michael, can you set the datum and projection for your incoming GPS data stream, and does it re-project the user-selected data stream to whatever datum or projection the user selects?
That is actually in version 3.7, so that will be available in early July. That is the real-time transformation and reprojection based on the datum. So for the sub-meter receivers and for the centimeter receivers, they are using things like in the United States, the BYOD system, which is referenced to a different datum than WGS84. So it's a next version that we have. We actually already do this in our desktop GeoPDF product. We support over 3,000 coordinate systems, datums, and projections, and we do that type of reprojection and transformation on the fly. So the geo specialists and geo experts here at TerraGo are very familiar with how to do this, and like I said, that'll be in version 3.7.
Okay, Michael, I'm going to ask you to step away from your device for just a moment and take a look into a crystal ball instead. Looking into the future, how do you see location-based services developing in the next couple of years, generally as a field? And what groundbreaking developments do you expect to see, and perhaps are you even preparing for now at TerraGo?
Well, I think the quick answer, if I'll start with the tail end of the question, I think we're preparing by being open. So I think what's coming, and we can all see this, we used to talk about Moore's Law with PCs, but the performance keeps improving at a pace far faster than industry analysts and pundits would predict. There was a GPS World article, I think it was last month, about the folks at the University of Texas who were able to achieve, centimeter accuracy using commercial phone equipment, right? So as clocks improve, as the antenna improve, as the boards improve and the chips and memory and performance, we're going to see us getting further and further away from having specialized devices required for getting GPS accuracy that meets the highest levels of survey-grade precision and accuracy. So I think that's one thing. I think the other thing is that the concept of the Internet of Things, which in all honesty I was never really sure how that affected our products until in the last year we've seen a lot of location-based sensors that we can attach to today, the TerraGo Edge. So just imagine, again, we can connect any GPS receiver, but you can connect any laser rangefinder. You can connect to things like barcode scanners. But on the location side, things like utility locators, like a 3M Dynatel that sends an electromagnetic pulse to find, fiber optics and gas lines and things that are buried. We can connect to all these devices because we have an iOS and Android capable open platform. These things are just things. They are the Internet of Things. They are sensors and peripherals. So I think that's what's really kind of interesting and disruptive about what's going on is that rather than looking at where the hardware is today, trying to predict your investments today based on hardware capabilities, this is an open mobile cloud-based solution that says, I can tap into the best GPS receiver, the best utility locator, the best laser rangefinder, and all different types of devices. So I really think that's what's exciting about the future is we'll benefit from all those peripherals as they increase the performance of these location-based sensors, even taking us indoors.
We've got a couple of questions coming in from Asia, again indicative of the international listening audience that we have here. I'll get to the second one in a second, but the first question, how is this supported in Asia in terms of maps and updates?
Right. Well, we have customers in Asia today. So the GPS receivers themselves depends on the type of networks that they use, but for example, are things like OmniStar, Worldwide Network. So there are lots of options for RTK networks to get centimeter level precision. There are lots of different systems for space-based augmentation systems. like WAS here in the U.S. and their equivalents in Europe and Australia and Asia. So it depends specifically on where they are, but this system is completely universal. And then as these GNSS receivers are capable of, the more satellites that are getting launched, will all just benefit as BYOD and these other systems and Galileo come online. We'll all benefit from greater accuracy from anywhere on the globe.
Here's a question combining Asia with current events. One listener references the recent earthquake in Nepal and wants to know how can TerraGo help to map earthquake-affected areas, and I think the subtext here is areas where perhaps there is no communication infrastructure.
Right. Well, the truth is TerraGo has been involved in the Japan tsunami recovery efforts. We've been in field data collection for some time. The best scenario that we have is for crews to be out there with these location-enabled devices and making observations that they can share. Now, sharing them remotely over long distances requires, network connectivity, clearly. A lot of our crisis and first response customers, and we have defense and intelligence customers, and we're actually an InQtel portfolio company, so the National Geospatial Intelligence Agency. But all the different crisis response and expeditionary units of defense and intelligence, they also have capabilities of setting up ad hoc networks. So they're able to set up things like private clouds and mobile clouds using all different types of communication techniques, and we can take advantage of those. But it's a vexing problem, of course, that we can do that. We also connect and can get satellite imagery, right? So as folks are taking pictures of various things like that and these terrible catastrophes, we are able, to share those with folks on the ground to help direct, the response and the recovery efforts.
So a similar question, is data saved in the device in case there's no connectivity for cell phones in the field?
It is, and that's one of the great things about it. So we have customers that have had, the big clunky GPS devices go out for weeks doing things like, environmental resources, wetland delineation, Alaska pipeline inspections. And if those devices fail, they literally lose weeks' worth of work. So what we have with TerraGo is the ability we cache and we store the data on the device. We're able to sync whenever you're back on the network. So it's kind of the best of both worlds. If you're able to sync, it's always getting pushed to the cloud and to other users. So you never lose that data as long as you can make a connection. But it's also limiting the window at which you might lose data, because you can go back to a Starbucks or the hotel or get on a Wi-Fi and sync up and be able to do that, even if you don't have connectivity in the field. So you can work offline maps. You can work offline and capture your data and not lose it. And it will synchronize whenever you get back on the grid.
We have two listeners specifically wanting to hear about security. One of them asks, please discuss the security of recorded data, and another one wants to know how secure is the crew locator?
Okay. There might be two different questions in there, so I'll talk a little bit. The security framework that we created TerraGo Edge is not a public cloud architecture. It's a private cloud solution. So that means that your server is never co-located or commingled with the data of others. Clearly, network security, if you're installing it on premise, is going to be completely up to how you organize your network and how you prevent intrusions to that server. We have a carrier class data facility that's used by some of the largest companies in the world. So we have world-class security and vulnerability monitoring for our hosted edge solutions. And like I said, there's no opportunity for data collision because we have dedicated servers, and we've chosen a private cloud architecture for that reason. The other question was, how secure is the monitoring of employees? So there's two different things to that. You set the policy to monitor employees or not monitor them. We also, due to privacy concerns, give the employee or the end user the ability to not share their location. So they have to declare to share their location and support that in the workflows. So in that way, we can balance kind of the general need for privacy as well as the desire for security. And one of the great examples of that use is that we have folks getting dropped from helicopters doing environmental research studies for Logan Simpson, and they're actually able to see where their employees are, and that's a huge safety benefit. So only they can see it. It's very secure. It can always be turned off when they're not on the job, but it's a huge benefit to the employee safety for a lot of our customers.
Can you set up point averaging capture with TerraGo? Basically, can you say that for any collected point, have it sample 50 GPS locations and give you the best average location? It's a good way to, traditionally, to increase your accuracy. Is this something that's accommodated by TerraGo?
It is. We actually store a revision of every note captured. So if you go out in the field, you take a GPS shot of a particular, and again, we call them a note, if you're taking a particular point, and then you get better reception or better satellite visibility, and your performance improves, and you take another one, and you take another one. We store all those revisions. We never throw any of that data away. On the back end of the server, what it enables is for you to run computations and averages for a particular note set. So you can actually do that type of averaging.
One listener wants to know, can we bring in geo-referenced JPEGs that we've created previously?
Geo-referenced JPEG. The answer to that, unfortunately, today is no. You can bring in GeoTIFF and GeoPDF and any geo-referenced PDF. Today, the customers that we have doing JPEG and those types of images actually use a companion product from TerraGo. So I guess it's possible, but you have to give us more money. It's called TerraGo Composer. And Composer allows you to turn any image into a geo-referenced offline map that you can take anywhere in the field. So within TerraGo Edge, the answer is not today, but you can do it with TerraGo Composer.
But so basically you do a conversion, and then you can?
Yes.
A conversion of the file, yeah.
That's correct.
We have one listener, at least, who's still a little bit confused. Just clarify the point. He thought we would not need an external device for sub-meter accuracy, but the case is that you do need an external device. Just clarify that for him, would you please, Mike?
That is 100% correct. If you need sub-meter accuracy, there's no phone, no commercial device available today that meets that requirement. There are some emerging tablets and things like that that are claiming that they're capable of that type of performance. And again, these are Android devices. You can run TerraGo Edge on them. But I'll let those manufacturers speak to their accuracy claims. To the best of my knowledge and to my access to our real geospatial experts, there's no way to get sub-meter accuracy from a commercial phone or tablet today.
Here's a peripherals question. With phones and tablets, especially in the cold in the field, what about external power sources, as the iPhone is not going to last all day with data use and Bluetooth? How are your customers addressing that issue?
So a lot of our customers choose various ruggedized options. Lizard is one of them, where they have IP65 rated, tablets, their iPads or Android tablets, and they're able to withstand water immersion and extreme temperatures, and they also come with supplemental battery sources. Typically, the GPS receivers, again, have different charging options and things like that, but at the high end of the receivers and the low end of the battery life, they're typically about 8.5 hours. So if customers are going out into the field and doing that type of work, a lot of our customers choose to just simply buy a ruggedized tablet or phone companion that has an auxiliary battery with it, so they can perform a full day's work without needing access to a power supply.
All right. Mike, we're nearing the end of our questions submitted, so we're going to wind up the webinar in a few more minutes. We've nearly reached an hour's time. We have plenty of time left, though. I'll pull a few more questions, but in the meanwhile, I want to give you a chance to perhaps recapture some of the important points from your presentation and any insights that you have gleaned about our audience from the questions they're submitting. Do you want to take a couple of minutes to do that, and I'll return with a few final questions?
Sure. I think my one message to the audience would be that while it's a pleasure to be here speaking in a webcast type of a presentation, you can never really have the interactivity that we could get from a one-on-one demonstration. So we have a team here that's able to show you the product in detail, talk to you about the receivers. We also have a network of GPS receivers, dealers that are out here that can help you understand your options for hardware devices when you need it. The truth is, this reminds me of 25 years ago when mainframes were, being the resistance to change of moving from mainframes to PCs. Some people could see that it was inevitable. Others were clinging to an ecosystem that they were very used to, and it's very understandable. So what I would ask people to consider today is, don't think you need to throw out your Trimble devices. These TerraGo Edge will work side by side, update the same backends. It's a very low cost, very low risk option, and whether it's TerraGo Edge or another solution, the truth is BYOD, mobile devices with GPS receivers, is the future for these types of applications. It's far too powerful a platform that you have with Google and Apple and Samsung and those folks with you. The performance is going to get better, but it's just a much superior solution than living with outdated software and proprietary handhelds. I think it's clear for our customers that have done this, they are thrilled. They've saved a lot of money. They're doing better work. They're getting better features, better performance. So I think it's clear, at least to TerraGo and our customers, that the future of open GPS is really the right way to think about where we're going. And you don't have to make a huge leap or take a risky deployment or sacrifice the ecosystem you're comfortable with to experience that. So just take a trial, try it. It's a very low-risk way to prove to yourself that this is a much better way to do GPS field data collection.
All right, since we're talking about the mobile environment and all the changes that it has brought, one listener wants to know, in that sense, or in the kind of the business model of much of the mobile environment, is TerraGo a one-time purchase, or is it a monthly subscription?
It's an annual subscription. It starts at $30 per month for a user, and then it goes down from there. So it's basically, and it's all in one. I can't overemphasize that. If you come back and you ask us for georeference JPEG support and you're a customer, we're just going to put it in the software. Everybody will benefit from having these types of options. We're not going to sell you another module. In addition to not having outdated hardware and software, we also don't have outdated software practices where we're trying to sell that. We actually just want to make you a customer, have it be simple, all in one, no tiers, no hidden credits, nothing like that. It's just a very straightforward price. And you can go to the website. It's all transparent. In fact, you can buy it online, and it's a simple annual subscription, and you get everything you need.
All right, a couple of technical questions or particular questions that may fall into that category that you just mentioned as we close out. One listener wants to know, can a geoid separation Z-value be set for real-time data collection?
Yeah, that's really on the receiver side. So I would actually answer that question with EOS or SX Blue, depending on the receiver that we're talking about. Again, TerraGo is just capturing that raw GPS data from the receiver. So the type of correction is actually being performed by the firmware on the GPS receiver.
Okay, and then on the sort of on the software side, perhaps in the area of compatibility with Esri and other things of that nature, can TerraGo support relationship classes?
Yes. So again, the ability to pull the data out of ArcGIS or any other geodatabase and maintaining the attributes of features and attributes of features and feature classes and bring that in is inherent to the integration with, for example, the ArcGIS platform. So you bring in those shape files and they maintain the integrity and structure of the data and its relationships, and they do so on the way in and on the way out.
Okay, a final technical question. You mentioned several specific brands of GPS in the presentation. One listener wants to know, is Terago able to take in any precision NMEA string for RTK?
We are, and it would be a little bit involved, but kind of quickly the idea here is that we are completely open. So whether it's a Garmin device or a Trimble device or SX Blue or EOS, we can actually take that NMEA data and you can use that as your receiver connected to your phone or tablet. Android is a little bit more open in that regard, so there's a nuanced difference between Android and iOS. For the iOS devices, you actually need to integrate what's called an SDK from those GPS manufacturers. So, for example, you can do that with some Trimble devices, not others. So it depends on the device if you're on iOS. On Android, it's a much simpler and cleaner and open integration. But we can support any NMEA compliant GPS receiver.
Now we've reached the end of our question list. Michael, I want to thank you very much for the breadth and depth of information you've provided today. Give you a chance to make a final summing up, and then we'll bid farewell to our audience. You've got as much time as you want.
Okay. Well, I won't take any more of their valuable time other than to say my email is being shown to the audience now. Please feel free to reach out to me directly. I'm sure we can have a much more productive conversation based on your unique requirements than is possible with the webcast. But so I hope it's been informative. I hope you'll at least take a closer look at TerraGo Edge and give some thought to an open GPS solution that will work on these modern mobile devices. And thank you again, Alan.
Thank you, Michael. We've been talking with Michael Gundling, the VP of Product Management for Terago. This has been a webinar presented by GPS World. Our next webinar will be in the month of June, June 18th. We'll turn to quite a different topic, which is driverless cars. Back over to our producer, Bethany Chambers, and thank you to all in our audience for attending. Bye now.
Thank you, Alan, and thank you to our audience for attending today's webinar. If you have any more questions, do not hesitate to contact our presenters at the emails on your screen now. An on-demand recording of today's webinar will be emailed to you tomorrow afternoon and will be available online for a full year at gpsworld.com/webinars. If you'd like to share this webinar with your colleagues, you can do so via any of the links on the left-hand side of your screen. You can also download today's slides and see the links that were referred to during today's presentation, such as the ROI calculator and app downloads, by clicking on the green folder icon at the far right of your dock at the bottom of your screen. If you aren't already a GPS World Magazine subscriber, we'd like to invite you to sign up today for free. All you have to do is click on the GPS logo in the dock and fill out a short form. Our next webinar, as Alan mentioned, is scheduled for Thursday, June 18th at 1 p.m. Eastern, 10 a.m. Pacific time. Registration for that event, The Road to Driverless, Autonomous Vehicle Platforms, Sensors, and Requirements, is now open. Again, you can register for these upcoming events or view previous events at gpsworld.com/webinars. We look forward to seeing you at a future webinar. Have a nice afternoon.